we landed is something I'm really proud to offer to the open source community, that the running joke is that I start things but I don't finish them. And K8s was able to come in and take my 90%, 80% product and build it into something really robust.
Imagine that there's this amazing club that everyone wants to go to, but there's effectively two types of bouncers that you have to pass through before you can actually enter the club, or the Kubernetes cluster in this case. And this is basically the Kubernetes admission process. You go through admission, mutate, 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 1 to n mutates, and then validate, 1 to n validates. You enter the cluster, and then it's the watch process.
All right, welcome everyone. This is Defense Unicorns. My name is Jeff McCoy. I am the CTO and co-founder. And today we're talking about Pepr. Before we dive into Pepr, though, I wanted to give you a little background on us, who we are, and what we believe in case you haven't heard of us before. So Defense Unicorns, we are a company that focuses deeply on open source. We build platform engineering tools. We look to solve problems in automation and making systems work more naturally and seamlessly, taking away the low-level annoying stuff to make things more scalable and secure. We focus on security first, defense in depth, building systems that aren't just paper security, but are real. And we try to mix deep Silicon Valley talent with deep government talent to bring together this really unique open source vision that, if you look across the globe and across the defense industrial base, we are literally one of the most unique open source companies out there. Pepr is one of those projects. So when Defense Unicorns, we think about building and we think about bringing things to market, we always try to bring open source to bear. We are in the top 20 contributors globally for Kubernetes. So we're deep experts in Kubernetes as well. We have core contributors on the Kubernetes teams, helping to bring that technology forward into the future. And we try to marry that with the needs and the demands of the Department of War, so that we can create secure systems that are a strategic, making software a strategic deterrent. And what we mean by that really is we want software to be so effective and so frequently updated that it deters other nations from trying to use speed and agility as a tactic against us. You've seen this in Ukraine with jamming of signals, with SpaceX response to that from Russian aggression and trying to jam SpaceX signals to Starlink, and the ability to rapidly respond to that. So everything we do at Defense Unicorns is about bringing these secure systems, rapidly deploying them, and doing it in as much of an open source fashion as we can to really raise the bar for everyone across the entire Department of War. So Pepr is a unique offering. It's one of our open source offerings, and we're here today to talk about its 1.0 milestone, and it's been I guess 2.5 years now, 3 years. I lost track of time, but I created it 2 or 3 years ago as a small project to answer a key problem of this kind of unique automation problem that we have. So by this point in the company's history, we had been building lots of systems. We were delivering lots of systems. We'd starting to see these repeating needs or patterns of automation that were bash scripts, that were maybe they're custom controllers, custom operators in Kubernetes, but that's kind of a heavy lift for a lot of people to maintain. But other ways you could do it with infrastructure as code, Tofu, or Pulumi, or other tools. But we felt like there was this missing layer there. And there are things like Kyverno or other really great policy engines as well, but those also didn't quite fit the unique problem space we were in. And one of the ways I would describe this problem when I first pitched it was when I was in the military for 18 years, I saw these patterns emerge where you would have these contractor experts, particularly downrange when we're deployed, who really knew exactly how to tweak a system to make it work when a condition occurred. So they've seen the same pattern 20 times, 100 times, 1,000 times, and say, oh yeah, here's what you do. You go and you go push this button, and then you go do this thing, and you go do this thing, and then it works. One example was for Kessel Run, for Jigsaw, the first application we built for Kessel Run. There was this tool that had this particular set of steps you had to do to make it work. So there was this dialog box on the Windows application, and you had to click in certain spots in the dialog box that made no sense at all. They weren't buttons. It was just you click here, okay, now you click here, and then you click here, and you click here, and that will fix this bug. So with some UI rendering bug in a Windows application, there were buttons or a sequence of events there that were occurring, and through some crazy I don't even know how they discovered this. They found some way to navigate and make this work. And so we saw this kind of pattern emerge through other things. We've seen this with Istio in the past as well, certain things it needed to trigger. And I'm sure Micah will tell you more about that. But I think this kind of idea of like, there's this built-in legacy knowledge that people have when they maintain a system over time that they build up. And one of the ways we codify that is through bash scripts or through documentation or through checklists. The military is very famous for checklists. My hypothesis was, what if we found some way to make it somewhat accessible in a language that is using plain language or fluent language to describe the problems and solutions? And what if we combine that with strong typing? Well, the problem is like that one of the ways to do that is TypeScript. TypeScript itself can be kind of verbose and very difficult to learn for people, especially as you get into complex typing. So we wanted to give it plain language, fluent-like API, which I'm sure Case will dive into. But we also wanted to make it actually be enforced through type checking automatically to validate it, which is something that even tools like Kubernetes do out of the box. It's as you're writing, you're getting feedback if it's right or not. You're getting type completion as you're writing. And so we chose TypeScript, and we combined that with this Fluent API to give a way to describe problems and solutions and to validate them. And that turned into a policy engine. I think where it started, we didn't know exactly where it would land. It was kind of built generically as like, we know we needed some automation help here, some glue, but we didn't know how far it would extend. And what it extended to was even to operators, and which they'll talk about later on as well, and how you can build full-blown complex operators off of the same kind of infrastructure and framework without knowing, key builder or controller runtime or client go or the other things that you typically would see in this space. It made it much more accessible for us and our teams, for people who were doing new JavaScript, TypeScript, to build operators or to build policy engines, which was quite novel, I think. And so the end result is this tool that kind of captures that legacy knowledge, codifies it into code, and makes it a responsive configuration as code based on demand signal, right? So it could be a policy engine, it could be an operator, it could just be a weird thing doer that fixes things that are wrong. And so I think that's kind of where we ended up with it, and where that fits in the larger ecosystem for us is it's part of the core offering of UDS Core. We leverage Pepr. We leverage Pepr to build what is UDS Core, which Michael will talk more about. And so I think that is part of that core glue that we saw over and over. We've deployed Kubernetes literally for years and years and years into classified environments. We've seen all the weird gotchas. We've got all the t-shirts. We've got all the band-aids and all the war stories of all the ways Kubernetes can go wrong on critical systems, on aircraft, on submarines, and everything in between. And we found we needed this tool to fill this unique gap. Maybe it's just unique to Department of War. I don't know, but it's what we've seen. And we feel like it really has proven itself over and over. And the last point I'll say is as we dug more into the operator side, into the lifecycle side of what is an operator, what does a Kubernetes operator actually mean, what is a controller lifecycle, we found ways to tune what's called the informer pattern further and further. I mean, we could really scale up. We were testing in the thousands and tens of thousands of operator actions and just bombarding Pepr just to see how far I could push it, to make sure we really understood the kind of the breadth and the scope that Pepr could leverage. And where we landed is something I'm really proud to offer to the open source community, that I haven't maintained this code for 2 years. Case has been leading it, and he's been really driving home this product. So Case and Micah are going to take over from here, but Case has been the lead engineer for Pepr. He did a phenomenal job. Just for those that don't know me, the running joke is that I start things, but I don't finish them. And Case was able to come in and take my 90%, 80% product and build it into something really robust with some other engineers as well, and just make it a really great long-term sustained project. And Micah, as the lead for UDS Core, has been really showing us how to take Pepr, to build the operator with it and to run that into integration and really push the boundaries of what integration means for a very unique experience that buys down complexity and buys down technical debt for teams as they scale up and use UDS. So Case, over to you.
Thank you, Jeff. Appreciate that. And before I get started talking about actually what Pepr is, I want to say a shout out to Sam, Barrett, and Kim, who have also done a phenomenal job on Pepr. Like your work has been instrumental. So like, thank you. And obviously we got like a really complete project when we got Pepr from Jeff. So we're talking about like Pepr and we're talking about admission and operators, but like, what does that even mean? And I want to give like kind of a metaphor to take this very kind of technical context and make it so everyone can actually understand it. But imagine that like there's this amazing club that everyone wants to go to. So it's like, it's a club, it can be like a golf club, whatever kind of club, but there's like a line of people that are waiting to get into the club. Well, the problem is the club has like very strict dress code criteria. And this is like obviously a really high level metaphor. But there's effectively like two types of bouncers that you have to pass through before you can actually enter the club, or the Kubernetes cluster in this case, and get into etcd and whatnot. But the first is called the the mutating bouncer. So it's like the mutating admission controller. But the mutating bouncer, there can be one, there can be 10, but there's just this row of mutating bouncers that are sitting out of the club. They're like, hey, next, please. You get to the mutating bouncer. The bouncer says, hey, look, this club requires a sports jacket in order to get in. And you don't have one, but we actually provide sports jackets. So, hey, you can go in. So give you the sports jacket, go to the next mutating bouncer. The next bouncer says like, hey, we are like, doing some exercise and stuff. So like rings on your finger are very dangerous. So we're going to take off your ring. We're going to save it for you because we don't want any kind of accident like getting pulled. So all of these mutating bouncers, they can add things or they can take things away. So next, after you get through all the mutating bouncers, you get to the validating bouncers. And so what these validating bouncers do is they ensure that you actually have the jacket on, or are you wearing jewelry that could actually like hurt you later. So it's the job of the validating bouncer. Let's actually make this actually, this is the Kubernetes admission process, right? So it's the job of the validating bouncer just to look over your clothes, your attire, and say, do you meet the criteria to enter the club? So the mutating bouncers can change things. The validating bouncers can reject or deny. They can say you can't come in or you can come in. And then you finally enter into the club or the cluster. And then this is where this watch process works. So at this point, you are in etcd, you are in the cluster, and now what the watch says, what the watch is basically bouncers that are hanging out inside of the club. And they're walking around, making sure there's no boisterous activity, everyone's abiding by the rules, making sure everyone's still got their jackets on, they still have, the rings on. But what the other bouncers do, with the watch bouncer, if you will, this is the Kubernetes informer, is it maintains order inside of the club. So this is basically the Kubernetes admission process. You go through admission, mutate, 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 1 to n mutates, and then validate, 1 to n validates. You enter the cluster, and then it's the watch process. So interestingly enough, when we first got Pepr, I don't recall, Jeff, you can correct me if I'm wrong, but I don't remember if we had what. I don't know if we had watch or watch was brand new. I know we didn't have Reconcile.
I think it was during our transition. We were working through it.
Okay, yeah, that makes sense. And so what the watch enabled Pepr to do is act on resources that are already in the cluster before Pepr. So that was something that we were starting to realize, right? At first we were saying like, hey, look, we looked at really great policy engines, right? We looked at Kyverno. We knew about OPA. We knew a lot of things, but we were looking for this very specific API surface that Jeff was just talking about, one that reads like plain English. So we couldn't like use something that would kind of fit. In this case, we had to kind of make our own, forge our own here. Able to do more with the things that already exist in the cluster. And we need to basically have a way to process things in a given order. So that's when we started really working on the watch and the reconcile. So basically what these do is, this is the Kubernetes informer. Kubernetes Informer is like this. It's like I call up the Kube API server and I say, hey, let me know if there are any changes in config maps. And every time a config map changes, I store that change in every 10 minutes. Every event, I cache it locally, ephemerally, really. And then I'm doing a relist like every 5-10 minutes. It doesn't really matter. But when I do a relist, I'm calling Kubernetes again, saying like, hey, I just want to verify, like, give me a list of everything I'm watching. Let me make sure my internal cache is right. And so on that relist, when I get the list of new objects back from Kubernetes API server, I compare the resource versions. I say, is one newer than the other one? So is this thing I just got back actually newer than what I got in my cache? If so, is in general. And then so I talked about watch, which is like at the very end of that slide. We also have something called Reconcile. And what Reconcile does, like this is like the operator SDK world, really. But it processes the events in a queue. So, I mean, imagine like you have an abstraction. I'm going to save this for Micah because he's going to talk about the UDS operator. But an operator is a way to simplify like very complex deployment. And I'll kind of get into a more simple scenario. But imagine you have a web application, and the web application consists of a deployment. The deployment has environment variables that say like the color theme is light or dark. The language is like Spanish or English, and then it has the service and the service account role by name with. Well, what I want to do is I want to deploy the same web app 10 times, and I want to say like change the color. So I want to change it from light to dark, light to dark. What a reconcile pattern does is it guarantees that the order in which they get to Kubernetes API server and Kubernetes API server gets into Pepr is the order that they're processed in, which opens up. Now, before I kind of pass this to Micah, I want to talk about like high level, like what are some things that you might want to do with Pepr or an operator framework or, admission controllers in general. One, like we in applications and in applications in general, like the industry standard, industry best practice is that your banking application, whatever your business use case is, doesn't have to necessarily know like auth-in through auth-z, Istio, traffic routing, security. Like every single application has totally different opinions on security. That might get very messy, right? Like how are you going to keep them all in sync? And every single application has their own like opinions on routing. We like to handle that globally. So admission framework and operator framework, but like you can have a global security posture. Everything that comes into my cluster, into my club, must meet a very specific security posture, right? Like I don't want things running privileged. I don't want things running as root. I don't want to get hacked, right? I don't want someone to backdoor out of the pod, get onto my node, install a crypto server or something, or blockchain mining. I don't know. So like there's a lot of things that are really great. And yes, I came from an operator SDK background. I was writing operators at Red Hat. And the thing that really stood out, right? Like the API is so obvious that it's made to reduce the barrier of entry. Like no longer have to know Kubernetes client Go. The API is so simple, but it's baked in with Kubernetes best practices like server-side apply. So you're having minimal network pressure. It has support for Kubernetes sub-resources. It's been battle tested across huge scales. It's just really, really good. And so I'm going to pass it over to Micah, who's the tech lead for UDS Core. And Micah, let me know if you want me to change
if we
slides.
can go to the UDS Core slide. Yeah, perfect. All right. So yeah, I want to start with kind of a high level of what does UDS Core provide and where does Pepr fit into that for those who don't know as much about Core. ultimately, UDS Core is a secure runtime environment or platform that runs on Kubernetes. It provides you with just a number of different services, and you can see from these pictures on screen, they're mostly just other open source tools like Grafana, Istio, Keycloak, Loki, Prometheus, and then we also have Pepr in there. So Pepr for a policy engine, which both Case and Jeff kind of talked through what Pepr provides generically there. And then we also use it for integration and as our UDS operator. So it fits really well and kind of ties together all these other tools and technologies for really seamless for those applications at that top layer here. So if you're running your own custom app or you're running something else open source like GitLab or Mattermost, you can really simplify what that looks like to run those securely with the UDS Core. The place that we use Pepr is for our policy engine, and I think one of the really cool things about Pepr, and we can switch back to the policy slide there. One of the cool things about this flow here is that we hit the mutating admission phase before validation. And what that gives us really is the ability to fix problems before they actually occur. So there's cases where you might not be able to modify the application you're deploying, and maybe it doesn't really meet your security best practices. So for some reason it runs as a root user, but you want a policy that denies root user running. And so you can use that mutation, change it to a different user. And that's something we've really leaned into with Core. So for a number of our policies, we're able to kind of resolve those potential issues before it hits validation. And then when it gets to validation, you're guaranteed that it should pass validation unless there was a explicit reason to need to bypass it. And in those cases, we do support like exemptions for policies. And really, again, because it's TypeScript, you have access to all sorts of like complexities that you could do in your checks. We've done things in the past where we look deeply into the spec of a container to make sure it matches like an Istio proxy to allow some more advanced privileged access, where an Istio, you really don't want to check things like that based purely off just the name of a container or something else. And so having the full access to everything that's in ultimately like a pod spec, you can check any field you want and use that in the validation. And again, back to kind of some of the TypeScript aspects and the Fluent client and Fluent like aspect of this, you can very easily read most of what's on the screen. Hopefully, it's when something is created, you mutate to change something, and you validate that something is set correctly, and then you either approve or give. And then, since it is TypeScript, you have access to some kind of the standard tooling and testing tooling that you get with TypeScript. So you can use things like Jest or Vitest to run unit tests, and that's again what we do to simplify the testing around our policies even. And then, moving on to the UDS operator. So this is really a big piece of where we pull in Pepr, and we do a lot of integration of applications with a lot of different technologies. So I mentioned earlier, like Keycloak, Istio, and Prometheus. So those three, when you're bringing a generic open source app or you've written your own app, you don't want to have to manage SSO yourself or all the complex Istio custom resources. And so we looked at ways to abstract that away into a single simplified interface. And so we've created a package custom resource that, back to the basics of Pepr, we're watching for a package custom resource, a bunch of different dependent configurations and resources that integrate with how you do SSO and how you expose an application through Istio, through an ingress gateway, and then how you get your application monitored through Prometheus. And so all of those are like kind of complex things that you might have to have specific domain knowledge normally to be able to configure. And by using Pepr as that integration point with our package custom resource, we can expose a more limited and simplified interface for end users where they just have to know, hey, I want SSO for my app. And they tell that to Pepr. Pepr is watching for that. Pepr sees it. It can go make API requests, right? It doesn't have to be strictly making other resources. It can do network calls, client. And that's kind of the basics of our operator. And then beyond that, there's some other things that we do along the way, right? For different situations that just pop up. And over the past year or two, there were definitely a few with Istio where there's certain scenarios where you need to kill an Istio proxy to allow pods to terminate, for example. And it's one of those things where if you know that, maybe you'd bake it into your application. Maybe you'd write a bash script or a cron job or something, right, that always does that. But having the ability with that informer and watch pattern to actually watch for the location, that's pretty huge. And so that's some of the great places that we use Pepr. I think I'll pass it back to Case now if you have any questions or yeah.
Well, yeah. So literally, like, that's really awesome. Like, I've been so impressed with what UDS operator has done and how much it simplifies something, because like literally you are eliminating human error. You're eliminating the possibility to accidentally fat finger something or human fatigue. It's going to be the same because the controller knows how to configure Istio and knows how to configure Keycloak. So you're really like delegating that. So then whatever application CR, whatever abstraction is deployed. I did have a quick question for Jeff. And what about donating Pepr to some kind of a donation, OpenSSF, CNCF? Like, what would be your thoughts on that, or what are your thoughts on that?
Yeah, I think we have a strategy at the company around open source. We've talked about that, and certain projects we intentionally license Apache to with the intention of donation. Pepr is one of them. There's still a few others as well out there in our GitHub, and I think that the goal for us is certainly to partner with the right organizations and to do that. We've done that with Zarf. We've done it at Zarf last year, and it was a question. I think Pepr will do the same, whether it's CNCF or some other smaller organization. CNCF has a lot of stuff in it. There's other candidates as well. I think we're still exploring that, but for sure, Pepr will end up landing in a foundation at some point. That is the intention and the goal. We just have to find the right, contribution partners and then the right organization to donate it to. Because when you donate, you're donating the trademarks, you're donating the intellectual property. You no longer own it. It's owned by an independent nonprofit foundation, which is what we want to do. And we believe in that deeply. I think that will come in the future.
Got it. And kind of one more question in the same vein. When I'm like talking to people about Pepr, a lot of times they say like, "Hey, why is it TypeScript?" And I believe we've kind of we've addressed that like today, right? Because of like the API, it's so obvious. But let's just say, just chatting, if we were going to rewrite Pepr from scratch, and then two, if it could not be in TypeScript for whatever reason, what language would it be in?
Yeah, I think so fun fact, I originally wrote Pepr in Go, and then after 2 weeks, threw it away because I wanted to do Go plus some sort of JavaScript-like thing for the policy language, because I didn't want to create my own new language. Like, it's the meme about the new standards, and now there's 13 standards, and like I didn't want to create another language, another standard. I wanted to leverage industry standards. I didn't want to do YAML because that's like that makes everyone sad. I wanted to do something that actually had type enforcement and was readable. So it was going to be JavaScript fed into Go, but there was some issues with architecture. What tools supported JavaScript into Go? So I scrapped all that sort of over in TypeScript. I think that that's still the right call. There is some. I'm hoping for continued optimization around portability of the Node.js runtime, whether that be like a bun or a Dino or something else that's even lighter and more efficient than raw Node.js itself. I think that's an area for improvement. We have looked at Go again, and moving back to that. That's definitely could be a desire, but I think it's proven itself to be very scalable. Node.js is very scalable on its own as an event loop system. But I think it's okay. It definitely raises eyebrows, and then people are like, but it's in TypeScript and everything's Kubernetes and Go, and that's totally true. But Kubernetes itself is just an API, right? At the end of the day, that's what it is. It's an API, and we consume the same type definitions, the same open API specs as KubeBuilder would or other things would. And so like it's actually the same. That's why it's an API, is so you can talk to it with protocols. And that's what Pepr does. It does the exact same thing as the Informer pattern and controller runtime. Like it's no different. It just so happens to be written in a different runtime language. And so I think it definitely, people are confused, but it was really harkening back to experience. And as Micah said, like readability for operator developers to say, oh, okay, I see what this is doing. And in the case of things like Caverna, which are very popular and very powerful, we've seen some really bad abuses of Caverna's kind of policy language in the YAML. It turns into this very complex Boolean logic and trying to understand, like, what is this thing actually doing? And then it's very hard to unit test and to validate and to verify and to have that type completion and all those things that make it a better experience for the developer world. My thought was, let's just bring in that experience for free from a VS Code and kind of go from there.
Totally, that makes a lot of sense. And fun fact, we have dash days every quarter. Our company does dash days, and out of curiosity, I basically wrote the KFC Informer twice in Golang, one over gRPC streaming in a sidecar, and one with Nats. And I threw so many request status side by side, both of them, and we did not get better results with the Go Informer. So it's like, it's battle tested. It's been tested and tested and tested. I was like, I'm going to do something in Go. I'd like to play in Go. Anyway, so Pepr is unique. It's awesome. It's battle tested. It's scaled. It's got a great API. And so now we're going to actually move on to the Q&A. Let's look at the Q&A. All right, that's Sam. Hey, Sam. All right, so what's unique about Pepr's Informer and Reconcile queue system compared to operator frameworks? So the very first thing that I'd say is very unique about its Informer is look, Kubernetes client Go has shared Informers. They have Informers as a library. We built our Informer custom from the ground up based on research. So we did our research. We looked at how Kubernetes did theirs. We tried a lot of things, and Jeff was actually, it was kind of hitting on this earlier. Our Informer is configurable. So like you can actually configure like how frequently you might want to do a relist, things like that. We don't really miss events anymore, but if there is a lot of pressure on a network, you technically could, and I believe you can also do that in the Kubernetes Go Informer. And then the queue system, the unique thing about the queue system or Reconcile is you have three options for how you reconcile. So you can reconcile by kind, namespace, name. So that's like a pod in the default namespace with name blue. So every time blue comes, we're just like basically processing some workload. By just kind, so you can say like, I want to throw every single Prometheus service monitor in a queue and process them one by one by one. Maybe not what you typically do, but there are use cases where you might want to do that. And then there's like kind name. So yeah, you could, ignoring namespaces, if there's a blue pod in the colors namespace and a blue pod in the cars namespace, you'd process those two entities in the same queue. But for like 99.9% of the use cases, you want to go by kind, namespace, name. That's like the general and the defaults. That's what we do in UDS Core. But yeah, that's what's unique about Pepr. We give you a lot of control. Good question. Who wants to take this one? Me or you, Jeff?
Yeah, I might take this one. Well, the thing about operators, I think in general is, and gets confusing for people. Don't realize how many operators are out there in the wild. Like a lot of things have operators, and in fact, Darren Shepherd of Rancher fame and now I forget what they've called themselves now, the AI company, but he's a guy who built K3s. He's built some crazy simple examples of operators using like bash scripts only. Like you can literally make it down to that simple. It could be a kubectl call in a pod, and it could be an operator lifecycle, right? So it was like this wide spectrum of what is an operator. And what I like to tell people is it's an automation tool that leverages a streaming API within Kubernetes, right? The informant pattern is literally just subscribing to events, and it's responding to those events and doing something with them. There's some patterns that have emerged over time, and some good like practices we've seen in the industry. But by and large, it could be written in Python, Go, Bash scripts, Pepr, operator framework, key builder. There's no right or wrong answer here. It's just an API call and how you best operate the API call for your technology you're trying to employ. And so I think that like the beauty of this segmentation is, and the way that Pepr works as well, is it doesn't actually matter that you can have 15 different systems side by side, and it's fine as far as the specific technology. Now, when it comes to an actual isolation boundary between, let's say, workspaces or between workloads, within UDS Core, we leverage network policies when we can. So if we're doing Istio in Sidecar injection mode, what I consider legacy mode now, then we could use network policies. We have to combine network policies with other Istio authorization policies now because of how ambient mesh works and how the tunneling system works. So one interesting thing I tell people here that it's one of the most fascinating things I've seen with UDS Core team, with Micah's work and his team is when we moved from Istio Sidecar injection standard mode to Istio ambient mesh, the definitions, our UDS packages, those application CRs for the operator, didn't have to change their code at all to migrate from a sidecar injection of service mesh to an ambient mesh to a sidecarless pattern, which saved 50 megs of memory per pod, which is a substantial savings on a large system. There was no operator configured change required because the operator itself, or user configured change required, the operator itself said, oh, I'm now in ambient mesh mode. I'm going to apply new rules to maintain defense in depth and maintain network isolation, layer 4 isolation, without the user having to change things. So what would that scenario look like with Helm charts? I'm deploying Helm charts to do the same thing, right? There's platforms out there that do this. I have a Helm chart, I have a wrapper for that. I would have to go into every one of those Helm charts and modify them to no longer use network policies, but now to use network policies plus this new Istio rule set that I have to go figure out and kind of make it work and hope I did it right and didn't break something else. And that's times n number of applications. You have 100 applications, you're changing 100 Helm charts. It's just that simple. And all it takes is mistakes on one of those. And you could say, well, I can do customize, or I could do some other abstraction. Sure, maybe, but there's so much inflexibility there. And there's so much more thought of like, did I just compromise security on all these applications? I don't know. Let me test through this, right? That's the beauty of something like UDS operator, leveraging Pepr. We can do that strong isolation at the network boundary, even as we migrate from one service mesh, frankly, to a whole different service mesh with no user change. It's the same configuration for them. And this goes back to the registry and the air-gapped app store. We can have these packages that run tactical edge on literally fighter jets and tankers, etc., other platforms or submarines or other weapon systems, but can also run on a large data center, an AWS GovCloud that can run on Azure, on Google's cloud. So it really can go anywhere because the operator abstracts the variability there where Kubernetes doesn't quite meet the threshold of abstraction.
That's a great question. So there are literally, like, first of all, how you want to get involved with Pepr is the same as like any open source product, but that's github.com/defenseunicorns/Pepr. If you haven't given us a star, go ahead and give us a star. Pepr is an awesome product. We, as the maintainers, like, are always going to look for issues that get opened up, feature requests that get opened up. All of these things, the more eyes on it that we can get, the better it's going to be. And that's not unique to Pepr here, Defense Unicorns. That's Zarf. That's the same for Kubernetes Fluent client. Like, we completely are proud of our work, and we work out in the 100% open, so you can see how the sauce is made. So yeah, go to our GitHub, give us a star, join Kubernetes Slack and Pepr channel. We have meetings every 2 weeks for the community, so we'd love to see you out there. I want to hear this from both of you all. I want to hear Jeff and hear Micah. That would be interesting to see, like, what you all think. But I think it would be something that doesn't change UDS Core so much. Like, the API would have to be the same. All right, that's all for me.
Yeah, I actually, to be honest, I haven't thought about it much, because with 1.0, like, it is such a core competency for us now. I don't see where you would even go with a 2. Like, a 1.1, a 1.2, 1.3, sure, but a 2, like, I don't even know what that would be at this point. Micah?
Yeah, I think I would similarly struggle. I think along the way to 1.0, we had a lot of like new features that helped make kind of the operator pattern a lot easier with Pepr, and could definitely see more of those. But yeah, that's still going to be like feature releases, right? And not really sure what a 2.0 could look like. Yeah.
Jeff, go
Okay. Okay. Yeah. So the way that we built early days, Defense Unicorns, the company. So when we started Zarf, that was the first open source product we created, and we were like 8 people, I think, or 7 people, and I was, I think, the only product developer. Everyone else was kind of doing, delivery services work or business stuff, and Rob and Andrew, I think, chose the Pokemon kind of pattern. It was great. I was just building software, and Zarf came from, from the submarine, heritage on Zarf being a cup holder. So that was like, okay, cool. So let's make a water Pokemon for that, and so that was great. And I think it was continuing the Pokemon theme. I actually, I don't remember now why it was a dragon. Some said it's because we needed a fire Pokemon. Some said because it's spicy. I have no idea, to be honest. Like, it sounds weird. I helped pick the logo. Rob told me it's going to be a Pokemon dragon, and I had a lot of opinions about what it looked like, because Pepr looked very different for a long time. But I actually don't know why. I was so busy building the software. All I can tell you is that my only focus was building something and become a very serious person. The way I demonstrated to the company, my first pitch of here's Pepr to the leadership team was a Chuck Norris joke engine in Kubernetes. So like, that was my demonstration for how you use Pepr, was a Chuck Norris joke engine as you applied pods. So I don't know. That's who we are.
I want to just bring up one thing. I heard this today, actually, but so Zarf is a fire Pokemon, and Pepr is Zarf is a water Pokemon, I wanted to say, and Pepr is a fire Pokemon. So we need like the plant Pokemon next for something. But guess what, you all? This has been very fun. Come join us in our community. Pepr.dev is our website. Hit us up on LinkedIn, on Slack, and we look forward to seeing you all. And thank you all so much. Appreciate it.